Hi students, this video is on current electricity part 3. Here we will study the three important points: Ohm's law, resistance and resistivity. First one, Ohm's law. Ohm's law gives the relation between the potential difference between the two ends of a conductor and the current flowing through it. So already we have studied what is potential difference and what is electric current. So according to Ohm's law, the electric current flowing through a conductor is directly proportional to the potential difference across the conductor, provided the temperature and other physical conditions remains constant or same. So mathematically we can write the Ohm's law as I is directly proportional to V, or V is directly proportional to I, or V is equal to I into R. Here R is the constant of proportionality known as the resistance, so which depends upon the certain factors. We will discuss it in the next slide. As Ohm's law states, the current flowing through a conductor is directly proportional to the potential difference. Now we can verify it through experimentally. So for this, set up a circuit as shown in the figure. So it consisting of a wire XY of length L meter and an ammeter, voltmeter, and 4 cells are used here. First, use the only one cell as the source in the circuit. Next, note down the reading in the ammeter I for the current and reading of the voltmeter V for the potential difference across the wire XY in the circuit, and tabulate them. That means note down the reading I and V. Next, connect the two cells in the circuit and note the respective readings of the ammeter and voltmeter for the values of current through the wire and potential difference across the wire. So repeat these steps using 3 cells and 4 cells in the circuit separately. Calculate the ratio of V by I for each pair of potential difference V and current I. Next, plot the graph V and I and observe the nature of the graph. The plot of the graph between the current I and the potential difference V, the graph will be straight line passing through the origin, and the ratio of V by is constant. This ratio is called as the resistance, and it is known as the Ohm's law, that is V is equal to I into R. Okay, then what is the resistance? Resistance is the property of a conductor which opposes the flow of charges or current through a conductor. It is known as the resistance. So from the Ohm's law, R is equal to V divided by I, and the SI unit of resistance is ohm. So when you say that the resistance of a conductor is 1 ohm, so the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when potential difference applied across its end is 1 volt. Then we say that the resistance of a conductor is 1 ohm. Then I is equal to V by R. So we have written it by use through the Ohm's law. So the current is inversely proportional to the resistance. So that means inverse relation means what? When the resistance increases, the current decreases. So this is what the inverse law says. So I is equal to V by R. So if the resistance is doubled, then the current gets halved. Next, by using this triangle law of Ohm's law, we can calculate the potential difference, current and resistance. So V is equal to I into R, first one, I is equal to V by R, second one, and third one, R is equal to V by I. Now, on what factors the resistance of a conductor depends? We have to discuss here. This is a very important question for your examination. So, on what factors the resistance of a conductor depends? First one, the resistance of a conductor depends upon the length, area of the cross section, and material of the conductor. So how it is depends on length of the conductor. So the resistance of a conductor is directly proportional to the length. As the length of the conductor increases, the resistance also increases. And the second one, area of cross section. The resistance of a conductor is inversely proportional to the area of cross section or thickness of the conductor. R is inversely related to A. That means what? As the area of cross section increases, the resistance decreases. That means what? Current increases. And also the third one, resistance also depends on the nature of the material of the conductor. Different metals offers different resistances to the flow of current. This is also called as the specific resistance or resistivity of the material. So mathematically we can write first one, R is proportional to L, R is inversely proportional to A. So combining these two, R is proportional to L by A. Therefore R is equal to rho into L by A, where R is resistance, rho is proportionality constant known as resistivity, L is length of the conductor, and A is area of cross section. Here proportionality constant rho is known as resistivity, and its SI unit is ohm into meter. So conductors have a low resistivity and insulators have high resistivity. So that means the insulators does not allow the current to flow through them. So this is what the conductors and insulators. Insulators have high resistivity and conductors have low resistivity. And one more type of solids are what? Semiconductors. Their resistivity lies in between conductors and insulators. So this table gives you the resistivities of various